and welcome back to Clint's workshop. Okay, we're not in the workshop as you can see, but we're looking at a workshop thing that's important. What I want you to do is to have a look at this just for a short while. Oops. I've just got to adjust this because what I'm going to do is to concentrate on this, because I want to show this as a thumbnail, and lately I can't get the thumbnail what I want because it just gives me options of my mugshot, which you'll find very boring. But this little device here is something I made earlier. You don't know what it is, do you? No, you won't know what it is, because it's a unique product. It's a design I was working on. Now I think I've got sufficient time for the algorithm to let me select this object as a thumbnail. So I'll go back to my normal arrangement. I'm going to tell you about this. And what I'm going to be discussing today, and with this as an example, is the fits, push fits and sliding fits. Okay, so I don't want to get bogged down with the whole issue of limits and fits and British standard specifications thereof. It's can get very involved, and there's a lot of research to do on it. Just having a drink now. Yeah, well, I've not been feeling quite well for 3 weeks actually, and my wife as well, and she thinks we've been afflicted with this COVID thing. However, we're feeling a lot better now, and excuse me, yesterday I went into the workshop and I was going to do something in there. I was in there about an hour and a half trying to set something up, and the workpiece I wanted to set up had a mishap, so I was unable to do it. But before we look at that in detail, because that contains push fits and sliding fits, and I would like to say a thank you for my new subscribers. I lost one 2 days ago. Really upsetting. I must be doing something wrong. Anyway, I must be doing something right anyway, but here we are. I want to say a thank you for these subscribers. And they got some, the names that they come up with, it's amazing. It's very interesting. So we've got Vicod3N, who subscribed on the 14th of October. Thanks Vicod. Yeah, much obliged. And Andrew Warren, who subscribed on Wednesday the 20th of October. Thanks Andrew, I hope you enjoy the videos and things. And Dave Scouren on the 25th of 10th, thank you very much. And I don't know where everybody comes from. This I know there's quite a few in the USA. And we've got Fred Balloy on the Tuesday, on the 2nd of November, and Bard Hines on the 10th of October. Thank you, both of you, for subscribing. And a very interesting one here. So, goes by the name of All Hope Abandoned. Anyway, thank you for subscribing. I've already thanked you in a comment, as you'll know. You got some very interesting things there, and I hope that some other viewers will look into the comments that you made. It's a very interesting thing what you do with forestry. I was amazed, and it's linked to wood turning as well, which I don't particularly do. It's too messy for me, too dusty. And we've got another person recently on the 18th of November called Dread Zeppo. Thanks a lot. So thanks all the new subscribers. Much obliged. And I really need some more, folks. We seem to be stuck on 250 and I need 1,000, but we're 25% of the way there. Anyway, let's have a look at this. This is a project I was working on, so switch. Yeah, switch. Which the idea is it was a tilt switch, went to a certain angle and it switched off. It cut the power, and then when it came back up, it cut the power back on. And I was experimenting with this type of thing, and there's all sorts of switches that you can look at. You've got bimetal strip switches, and which work on heat, and then you've got to look at the coefficients of linear expansion and coefficients of heat and stuff like that. You don't need to go into all this, but what I'm going to do is, it's worth noticing, it's worth of note that when you do look at fits, push fits and slide fits, there's a whole section on it. You have a look if you want to research it on British standards, but I made this. I didn't make any reference to BS because I am aware of it. So firstly, we've got three different materials here. Well, you can only see two. Well, one's inside. So we've got an aluminium alloy at each end there, and then there's a acrylic centerpiece there. So let's have a look. Take this off, and this is a push fit. Look, I'm pulling it off. Oh, it's a bit tight. Push fit. There we go. And it's coming dark in here now. I'm sat by the window and it's coming dark, so I want to switch the light on. Might be a bit more constant. So that's a push fit for that piece. Look inside. So look inside on this. Oops. Where am I going to go? Oh yeah. There you go. It's got two machine bores. That outer bit, that's a hole for something. What am I experimenting with? So that's one piece. And then here this is stainless steel. So, and there's different types of stainless steel. This being a austenitic type stainless steel, which won't attract a magnet. Or the ferritic one type does. Anyway, the thing is, here's the other piece. And the aluminium bit there is a push fit on there. So, there, broke that. So here you've got the centrepiece there, which is like an acrylic material. I'm just trying to get the angles right. And now I've lost. I try to keep this the same, so it fits the same way for some reason. It will fit both ways, so I've just showing you. But anyway, I like to try to keep things assembled in the order they came out for other reasons. Let's have a look at this piece. Yeah, you've got a bow there inside, and that's the rim where the push fit is there. So the idea is that goes there. Push fit, I'll push it, and this is a push fit. We've got to get that lined up with that, which it should do. There we are. You can hear it. The thing is, that sliding fit is important, and yet I've got a hole there, because if I were to put it at that side, put my finger over the hole, it might not drop, but actually it did then. Oh, you can't hear it, it just dropped then. Never mind. And that's just to let the air move out as that little piston thing moves up, so it doesn't act as a compressor. Now, what I'm going to say is, you've seen the push fits, and now just look at that sliding fit. The sliding fit is important, and if you're doing sliding fits, it's always best to be aware of the materials that you're using, because I push this in nicely, just you watch me do that. But if I came down and left it overnight in a cold place or a hot place or whatever, I might have to use extra force to push it in, and that's because these materials, that acrylic material there and the aluminium, is they've got different coefficients of linear expansion. Let's not get too technical on this, but they expand at different rates, so they go colder, and one will expand at a higher rate than the metal. And for instance, I'll give you an instance on this. If you look at the coefficients of linear expansion for plastics, you get a figure of 40 to 120, okay, as a coefficient. Compare that with cast iron, which is only 10.4 to 11. There's vast differences. And well, forged iron, drop forged is 11.3. The ones we're looking at here, aluminium. So we've got aluminium. That coefficient is 21 to 24. Compared to the plastics, which might be 40 to 120, it's a vast difference. And that's why I'm having to use extra force sometimes, because of the linear expansion of the materials being different. And that piece in the centre, that piston thing, is stainless steel, and that has a coefficient of linear expansion of only 9.9 to 17.3. you see. But the aluminium is 21 to 24. Anyway, it's a bit academic. I know some of you are getting bored with it, but the thing is, you need to, I needed to, get this out here. Nice push fit. And then this stainless steel needs to go nicely in there. Okay. Now the other thing, I made this, and you remember me telling you on a previous video about accuracies you can get. You don't need micrometers. I didn't need a micrometer for that. Just did it with calipers and feel and touch. So you get quite a nice fit, as you can see, and it slides up and down that thing. So there you are. Slide that in that hole, and just to show you that I can put it in the other side. It's a bit constant, but you can achieve this. This is an example we can achieve just with calipers, and then when you get in there, you can do sort of trial and error. It's a question of experience, folks, you know. And the more you practice, the more you get better at it, you see. That's what it amounts to. I'm just checking the time on this. I don't want to make it too long a video. It's the first one I've made since I'm back in action again, as it were. I know I don't do many videos, but because I sometimes have to really feel in the mood these days to do them. I'm going to put this back on here. Sliding fit. Yeah. Now you can hear this thing. Right. So the idea is that this thing works as a switch. There's many switches on the market which are research, like proximity switches and tilt switches and different types, micro switches, push button switches. It didn't have the switch that I wanted, so that's why I'm preparing this. Now, okay, it didn't work. It worked, but not as I wanted it to, because when it went to the off position, then onto the on position, off on, and it operated a machine, but the motor in the machine, it got intermittent because there was a vibration set up, and that piston thing was bouncing. So, one for the fairy file? Not quite, because I'm going to find another use for this. And you might smile when I tell you, but I've got an idea to make this part of a sort of gift for one of my granddaughters. And it's going to be, she thought something else what I made was like a spaceship, and this is going to be a satellite launched into orbit in a spaceship. I'll tell you more about that later. But if you looked at that chess set I made, the bishop, when my granddaughter, she's learning moves in chess and things, and she's not quite 4-year-old yet, but she's interested, and she says, "Oh, it's a spaceship," and there you are. In fact, I think what I'll do, I'll show you just a minute. Whoops. There. Sorry, I should have paused the video, but that was a bishop. And she thinks, oh, spaceship, ooh, that was quite amazing, the way they're thinking. So the idea is that this can go inside that, and it makes a more realistic looking spaceship. What do you think? Oops. Well, you got to try these different things, and I like it anyway. I'll put this back. Sorry, I should have paused this video, but never mind. So that's all for today. But I tell you, I need more subscribers, please. All you several thousand of people are watching this for the first time, and some you find it interesting, some don't. But you know, if 1,000 of you could just give us hit the subscribe button, I'd be able to monetize my channel and maybe do other things, because it does cost money to run these channels, you know. It is an expenditure, and I don't make anything out of it, but I hope to come to monetize it if I live that long. Anyway, look, thanks for viewing. Much obliged, and keep switched on. And oh, you can check that out. That might interest you if it works. Okay, see you next time. Thanks for looking in. Bye for now. Keep safe.